You are stressed right now. Maybe not dramatically, maybe just quietly. The deadline that won't go away. The conversation you keep replaying in your head. The feeling that there is always something unfinished. That kind of stress. The low-level background, never quite gone kind. Here is what most people don't know about it. It is not just a feeling. It is physically changing the structure of your brain. Right now, while you live your ordinary life. And by the end of this video, you will understand exactly which parts are changing, by how much, and this is the part most people miss, what the research says about whether those changes can be undone. Researchers in Barcelona and Madrid scanned the brains of people living under chronic stress. What they found was structural, measurable, and it showed up directly on MRI. Their findings were published in Current Neuropharmacology in 2024. The full link is in the description. Everything in this video comes directly from that research. Now, let's get into it. Think about what happens when you are stressed. Your heart rate increases. Your muscles tighten. Your thoughts speed up. This is your stress response activating. It was designed for acute threats, something dangerous, immediate, and temporary. You respond. The threat passes. The system resets. That is how it is supposed to work. But for many people today, the threat never quite passes. Work pressure, financial worry, relationship strain. These do not resolve in minutes. They persist, week after week, month after month. And when the stress response is activated repeatedly over a long period of time, the brain does not simply reset. It adapts. And those adaptations, the 2024 review found, are structural, measurable on brain scans, visible in the physical architecture of the brain itself. The review identified 3 brain regions that are consistently affected by chronic stress. The first is the hippocampus. The hippocampus is involved in memory formation and learning. It is one of the most well-studied regions in stress research, and the numbers are striking. Meta-analyses cited in the review found that people with stress-related disorders showed hippocampal volume reductions of between 4 and 10% compared to people without those disorders. One meta-analysis of 13 studies found that PTSD patients had on average 6.9% smaller hippocampal volume compared to control subjects. These are not subtle differences. These are measurable structural changes visible on standard MRI brain scans. The primary mechanism is cortisol, the stress hormone that remains chronically elevated under long-term stress. High cortisol over time is associated with reduced neurogenesis in the hippocampus, meaning the brain produces fewer new neurons, and with dendritic atrophy, meaning existing neurons lose some of their branching connections. The second region is the prefrontal cortex. This is the part of your brain responsible for rational thinking, decision-making, impulse control, and emotional regulation. Think of it as the part of your brain that says, wait, think before you react. You are in a difficult conversation. Someone says something that stings. The prefrontal cortex is what lets you pause, choose your words, respond instead of react. It is also what lets you sit with uncertainty without spiraling. What lets you distinguish a real threat from an imagined one. What lets you think clearly when everything feels urgent. Under chronic stress, that system weakens. The review found that chronic stress impairs both the function and the physical structure of the prefrontal cortex. Structurally, it causes reduced dendritic branching and synaptic connectivity, meaning the neurons become less connected to each other. Functionally, this shows up in ways most people recognize but rarely associate with stress. Decisions feel harder. Small things feel disproportionately large. The capacity to regulate emotional responses weakens. The ability to think clearly under pressure diminishes. And crucially, these functional changes can occur rapidly, even before structural changes are visible on scans. The review noted that these functional changes can occur rapidly, even before structural changes are visible on scans. The third region is the amygdala, and this is where the research becomes genuinely counterintuitive. The amygdala is the brain's threat detection center. It processes fear and emotional responses, While the hippocampus and prefrontal cortex tend to shrink under chronic stress, the amygdala tends to expand. Structural changes, including increased dendritic growth, have been observed in the amygdala of chronically stressed individuals, potentially making it more reactive to perceived threats. At the same time, the prefrontal cortex, which would normally moderate that reactivity, is becoming less effective. The result is an imbalance. More sensitivity to threat, less capacity to regulate the response to that threat. This is the structural basis for something many people experience but struggle to articulate: anxiety that feels disproportionate to the actual situation. Your brain is not overreacting irrationally. It is responding exactly as its current structure predicts it should. Here is something the review highlighted that changes how you might think about this. These structural changes are not a sign of weakness. They are the brain doing exactly what it is designed to do, adapting to its environment. If the environment consistently signals threat, the brain reorganizes to prioritize threat detection. The amygdala becomes more sensitive. The prefrontal cortex, which takes energy and time to engage, becomes less dominant. This is an efficient response to a genuinely dangerous environment. The problem is that modern sources of chronic stress, work, financial pressure, social demands, are not the kind of threats this system was built for. The brain is adapting to an environment it is misreading as physically dangerous, and the structural consequences accumulate over time. Now, a critical eye. The 2024 review is a narrative review, meaning the researchers synthesized existing literature rather than collecting new primary data. Narrative reviews are more susceptible to selection bias than systematic reviews or meta-analyses. Many of the neuroimaging findings were based on patient populations with diagnosed stress-related disorders, PTSD, major depression, anxiety disorders. Whether the same structural changes occur in people experiencing chronic but subclinical stress, the kind most people live with, has not been fully established. And the direction of causality is not always clear. Reduced hippocampal volume may be a consequence of chronic stress, or it may reflect a pre-existing vulnerability that makes people more susceptible to stress-related disorders. The research has not yet fully resolved this question. But here is what the evidence does clearly point toward. These structural changes are not permanent. The review cited evidence that the brain's neuroplasticity, its capacity to reorganize and change, means that stress-related structural changes can be reversed. Hippocampal volume has been shown to increase with certain treatments, physical exercise, and psychotherapy. Prefrontal cortex connectivity can be restored. Amygdala reactivity can be reduced. One set of studies found that psychotherapy attenuated gray matter loss in the prefrontal cortex over 3 years in people with depression. Physical exercise has been linked to increased production of a protein called BDNF, brain-derived neurotrophic factor, which supports neuron growth and hippocampal recovery. The brain that chronic stress has reorganized can be reorganized again. That is not a promise. It is a finding from the structural neuroimaging literature. And it raises a question we will come back to in this series. If the brain can recover from chronic stress, what does the evidence say about how that recovery actually happens? We will get to that. Let's bring this back to where we started. That background hum of stress that most people carry. The research suggests it is not simply a mental state. It has a physical signature in the brain. Measurable. Consistent. Documented across neuroimaging studies. 3 brain regions, the hippocampus, the prefrontal cortex, and the amygdala, show structural changes under chronic stress. Changes of between 4 and 10% in hippocampal volume. Measurable reductions in prefrontal cortex connectivity. Measurable expansion in amygdala reactivity. These changes help explain why stress makes everything feel more threatening, why it becomes harder to think clearly, why small things start to feel large. Your brain under chronic stress is not failing you. It is adapting to what it perceives as a persistent threat. The question worth sitting with is this: if your brain is physically changing to match your environment, what does that say about the environment most of us are living in? And what would it mean to take that seriously? Leave your answer in the comments. The full study is linked in the description, peer-reviewed and published in Current Neuropharmacology. As always on this channel, the source comes first. Subscribe if you want more, and we will see you in the next one.